September 2001. Chevrolet quietly unveiled an engine so outrageous it sounded like something from a drag strip fantasy. 720 horsepower, 685 pound-feet of torque, 572 cubic inches of naturally aspirated American V8. It wasn't turbocharged, it wasn't supercharged, it didn't rely on hybrid technology or exotic materials, it was simply enormous. But there was one catch. In most of America, enthusiasts could buy it, install it, and unleash all that power. In California, however, that same engine faced a wall of regulations that made it effectively illegal for normal street use. Most people think it was banned because it was dangerous. But what almost nobody knows is that the real reason had nothing to do with horsepower. It had everything to do with emissions. And the story behind that decision reveals one of the biggest battles in American automotive history. To understand why the Chevrolet ZZ572 became a legend, you have to go back decades before it ever existed. Throughout the 1950s and 1960s, General Motors built its reputation on big block V8 engines that powered everything from family sedans to championship-winning race cars. Engines like the 396, the 427, and eventually the 454 became symbols of American performance. Bigger displacement meant more torque, faster acceleration, and an unmistakable exhaust note that echoed across drag strips and racetracks. These weren't just engines, they were cultural icons. The 409 became immortalized in song by the Beach Boys. The 427 dominated Daytona and won championships. The 454 LS6 in the 1970 Chevelle SS remains one of the most collectible muscle cars ever built. Factory horsepower ratings climbed year after year. Compression ratios soared into double digits. Performance seemed limitless. Street racing thrived. Drag strips packed spectators every weekend. Dealerships practically served as recruiting centers for the horsepower wars between Ford, Chrysler, and General Motors. Young buyers could walk into a showroom and drive home with genuine factory race cars barely disguised as street vehicles. But by the early 1970s, everything changed. New emissions regulations, the Clean Air Act, rising fuel prices, and skyrocketing insurance premiums crushed the muscle car era almost overnight. Compression ratios dropped from over 1 to around 8.51. Horsepower ratings collapsed. Legendary big blocks disappeared from dealer showrooms. The 1971 LS6 454 was detuned significantly. By 1972, even the mighty Corvette struggled to break 200 horsepower in base trim. Many enthusiasts believed the age of giant naturally aspirated V8s was over forever. The 1980s brought electronic fuel injection and computer controls, but performance remained restrained. Manufacturers focused on efficiency, reliability, and meeting increasingly strict federal standards. The traditional big block architecture seemed destined for the history books. They were wrong. As the performance aftermarket exploded during the 1990s, Chevrolet engineers realized thousands of enthusiasts still wanted massive displacement. Not for commuting, not for fuel economy. They wanted brutal torque for drag racing, hot rods, and weekend builds. Television shows like American Hot Rod and magazines like Hot Rod and Carcraft documented a thriving culture of custom builds that demanded serious power. Classic cars commanded rising prices. Resto-mod culture, blending vintage aesthetics with modern performance, gained momentum. That demand gave birth to Chevrolet Performance's most outrageous crate engine project. And then the real engineering challenge began. The foundation was Chevrolet's famous Generation 6 big block architecture. Engineers stretched everything they safely could. The cylinder bore measured an incredible 4.56 inches. Stroke reached 4.375 inches. Multiply those numbers across 8 cylinders, and the result was 572 cubic inches, or approximately 9.4 liters. For comparison, Chevrolet's legendary 454 displaced 7.4 liters. This new engine was nearly 2 liters larger. To put that in perspective, many modern turbocharged 4-cylinder engines displace around 2 liters total. Making an engine this large wasn't as simple as boring out an old block. The cast iron block required reinforced bulkheads, thicker cylinder walls, 4-bolt main bearing caps, and priority oiling improvements to survive tremendous cylinder pressure. At full throttle, enormous forces traveled through the forged steel crankshaft thousands of times every minute. Engineers also had to carefully consider cylinder wall thickness. Bore them too large, and the walls become fragile, risking catastrophic failure. The metallurgy of the casting had to be precise. Cooling passages needed redesigning to prevent hotspots that could cause detonation or warping. Every dimension represented a compromise between maximum displacement and structural integrity. Chevrolet paired that crank with forged steel connecting rods and forged aluminum pistons, running an aggressive 1:2.0-1 compression ratio in the ZZ572/720R version. Those numbers immediately revealed its purpose. This was never designed for regular pump gasoline. High-octane racing fuel was mandatory. Anything less invited detonation that could punch holes through pistons in seconds. Then came the cylinder heads. Massive aluminum rectangular port heads allowed enormous airflow. Intake valves measured approximately 2.25 inches, while exhaust valves stretched to around 1.88 inches. Those aren't typos. Valves that large meant the heads could flow enough air to feed nearly 9.5 liters of displacement at over 6,000 revolutions per minute. A solid roller camshaft provided aggressive valve lift and duration. Unlike hydraulic camshafts that use oil pressure to maintain valve lash, solid roller designs require periodic adjustment but deliver more precise valve control at high RPM. The valve springs had to be carefully matched. Too weak and valve float occurs, causing catastrophic contact between pistons and valves. Too strong and the Drivetrain components wear excessively. The engine breathed through a gigantic single-plane intake manifold topped by an 150 CFM Holley Dominator carburetor. For context, many ordinary V8s use carburetors flowing 600 to 750 CFM. The Dominator flowing 1,150 CFM could literally fill a bedroom with air in minutes. That flow capacity meant the engine never starved for oxygen, even at maximum RPM under full load. The result was astonishing. Official factory ratings reached 720 horsepower at around 6,250 revolutions per minute and 685 pound-feet of torque near 4,500 revolutions per minute. More importantly, the engine produced well over 600 pound-feet across much of its operating range. It didn't just make peak numbers. Dyno charts showed a torque curve that looked almost like a plateau, from 3,500 revolutions per minute to well past 5,500 revolutions per minute. The engine simply delivered massive, unrelenting force. That characteristic made it incredibly effective for acceleration. While high-revving engines might make impressive peak numbers, the ZZ572 delivered usable power across the entire range drivers actually used. But there was a problem. An engine producing that much torque created enormous stress throughout the entire drivetrain. Standard manual transmissions often failed. Automatic transmissions required racing internals. Rear differentials cracked. Drive shafts twisted. Even engine mounts sometimes tore apart under repeated hard launches. Clutches designed for ordinary performance cars lasted mere weeks. Builders quickly learned that transmissions like the Turbo 400, Powerglide, or modern Tremec 6-speeds with appropriate gear ratios were practically mandatory. Rear axles needed upgraded ring and pinion gears, stronger axle shafts, and limited slip differentials capable of handling the punishment. Chevrolet knew buyers weren't installing this engine into grocery getters. They expected experienced builders to reinforce everything behind it. Because if they didn't, the ZZ572 would quickly expose every weak link. Suspension became another challenge. That much torque could overpower tires instantly, breaking traction and causing dangerous instability. Chassis reinforcements, upgraded suspension components, and careful weight distribution weren't optional. They were survival requirements. Performance numbers proved just how serious it was. Depending on vehicle weight and traction, properly built cars equipped with the ZZ572 regularly produced quarter-mile times deep into the 10-second range. Some lightweight drag cars dipped into the 9s while remaining naturally aspirated. Top speed depended entirely on gearing, but with enough road, many builds comfortably exceeded 180 miles per hour. Street performance was equally dramatic. 0 to 60 times often dropped below 4 seconds in properly set up cars. Rolling acceleration from highway speeds felt like being launched from a catapult. The sheer force turned everyday driving into an event. Most people don't realize this engine wasn't designed for NASCAR, Le Mans, or Formula One. It belonged to a completely different culture. American drag strips, weekend cruise nights, pro street builds, restomods. It became the dream engine for enthusiasts who believed there was no replacement for displacement. YouTube videos from the era show ZZ572 powered builds absolutely dominating streetcar competitions. Chevelles, Camaros, El Caminos, and even custom hot rods received the treatment. The sound was unmistakable, a deep, thunderous rumble at idle that transformed into a mechanical roar under acceleration. But then California entered the story. California has long maintained emissions regulations stricter than federal standards. The California Air Resources Board, better known as CARB, requires emissions-related engine packages installed in street-driven vehicles to receive an executive order certification showing they comply with state emissions requirements. The certification process isn't simple. Manufacturers must submit engines for extensive testing measuring hydrocarbons, carbon monoxide, nitrogen oxides, and particulate matter across various operating conditions. The engine must meet specific limits for each pollutant category. Testing costs alone can exceed hundreds of thousands of dollars. The ZZ572 never received that certification for normal street applications. Why? Because this engine wasn't engineered around modern emissions equipment. It used a large carburetor instead of electronic fuel injection. Its aggressive camshaft created significant valve overlap, hurting idle emissions. The high compression ratio increased combustion temperatures. It lacked the emissions calibration required for certification in modern street vehicles. Carburetors, by design, cannot adjust fuel delivery with the precision of modern fuel injection. They work through mechanical principles. Airflow through ventures creates vacuum that draws fuel. But they cannot adapt to changing altitude, temperature, or load conditions the way computer-controlled systems can. That limitation meant fuel mixture was often richer than necessary, increasing hydrocarbon emissions. The camshaft presented another challenge. Aggressive profiles with significant overlap, where both intake and exhaust valves open simultaneously, allow some unburned fuel mixture to pass directly through the engine into the exhaust. That might improve top-end power, but it dramatically increases emissions, especially at idle and low speeds. High compression ratios raise combustion temperatures. Higher temperatures increase the formation of nitrogen oxides, one of the primary pollutants CARB regulations target. Modern engines use carefully controlled compression ratios, exhaust gas recirculation, and precise fuel delivery to minimize NOx formation. The ZZ572 had none of those features. In other words, it wasn't horsepower that California objected to, it was chemistry. Hydrocarbons, nitrogen oxides, carbon monoxide, those invisible gases determined whether the engine could legally power a street-driven car within California. And that's where countless enthusiasts became confused. Outside California, emissions rules often followed federal requirements or allowed greater flexibility for specially constructed vehicles and racing applications. Builders could purchase the ZZ572 as a crate engine and install it according to their local regulations. Many states had exemptions for vehicles over a certain age, for specially constructed vehicles, or for registered race cars. But California required much stricter compliance for street use. Even classic cars underwent periodic emissions testing in many counties. The referee program existed specifically to evaluate modified vehicles. Installing an engine lacking proper certification could result in registration denial, failed inspections, and expensive reversal of modifications. That single difference transformed the exact same engine from perfectly acceptable in one state into effectively illegal for ordinary road registration in another. Geographic location, not the engine itself, determined legality. You can probably guess what happened next. The aftermarket exploded with workarounds. Some owners built dedicated race cars, where emissions certification wasn't required because the vehicles never operated on public roads. Trailers hauled these machines to drag strips, where they competed legally without registration concerns. Others installed the engine in pre-smog classic cars, where exemptions existed depending on model year and local rules. A 1967 Chevelle, for instance, might avoid modern emissions testing entirely in certain jurisdictions, making the ZZ572 swap technically legal. Some enthusiasts transported projects across state lines, registering the vehicle in Nevada, Arizona, or Oregon while living near the California border became a common strategy. Others maintained dual residency or used family addresses in other states. Still others accepted the risk. Off-highway use, private property, and occasional careful street driving with proper exhaust systems allowed some builders to enjoy their creations despite questionable legal status. The consequences, if caught, could include fines, impoundment, or forced removal of the engine. The engine itself hadn't changed, only the legal environment had. Online forums exploded with discussions about legal strategies, technical workarounds, and frustration over what many saw as government overreach. Others defended California's position, pointing to Los Angeles smog, health impacts, and the collective benefits of cleaner air. Ironically, Chevrolet had already demonstrated it could build cleaner, high-performance engines. The LS family proved fuel injection, electronic engine management, catalytic converters, and careful combustion design could deliver incredible performance while meeting emission standards. The LS1, introduced in the 1997 Corvette, produced 345 horsepower while passing all emissions requirements. Later LS variants exceeded 500 horsepower from 6.2 liters with full emissions compliance. The technology existed to build powerful, clean engines, but the ZZ572 wasn't trying to be modern. It was deliberately old school. It celebrated displacement instead of efficiency, carburetors instead of computers, mechanical brutality instead of electronic refinement. That philosophy made it a legend. It represented defiance against the trend towards smaller, more efficient, more regulated power plants. It was engineered nostalgia, a modern engine built using traditional principles that many believed were extinct. Mechanically, reliability surprised many owners. Despite its extreme output, the engine proved remarkably durable when assembled correctly and operated within its intended environment. Large oil passages helped maintain lubrication under sustained high loads. Forged internals handled repeated abuse. The cast iron block resisted distortion despite tremendous combustion pressure. Owners reported engines lasting years of regular use at drag strips and car shows. Proper maintenance, quality oil, correct fuel, appropriate break-in procedures yielded impressive longevity. Some engines exceeded tens of thousands of miles with only routine maintenance. Of course, abuse always found the limits. Detonation caused by low-octane fuel could destroy pistons within minutes. Poor cooling systems led to overheating. Weak fuel delivery created dangerously lean mixtures at full throttle. Builders who underestimated the engine often paid expensive lessons. Stories circulated through the community. One owner destroyed a fresh engine during the first test drive by using pump gas instead of racing fuel. Another cracked a block by skipping proper break-in procedures. A third melted pistons when the fuel pump failed at wide-open throttle. Experienced mechanics had a simple saying: respect the torque, because the torque always won. The ZZ572 also wasn't cheap. When introduced, complete crate engines typically retailed for well over $20,000 depending on configuration and accessories. Once buyers added a suitable transmission, drive shaft, cooling system, custom exhaust, upgraded suspension, stronger rear axle, and installation costs, complete builds often exceeded $50,000. Some builds reached six figures. Custom chassis work, show-quality paint, upgraded interiors, and extensive fabrication pushed total investments into territory where buyers could have purchased exotic sports cars instead. But enthusiasts didn't care. Owning one wasn't about practicality, it was about emotion. Start the engine, and the entire car seemed to shake. The idle wasn't smooth. It was lumpy, aggressive, impatient. Crack open the throttle, and the carburetor inhaled enough air to sound like industrial machinery. Every stab of the accelerator reminded drivers they were controlling nearly 9.5 liters of naturally aspirated displacement. Passengers experienced genuine fear during full throttle acceleration. The violence of forward thrust, the overwhelming noise, the sensation of physics being temporarily suspended, it created memories that lasted lifetimes. Few engines deliver that sensation today. As emissions standards became stricter worldwide, manufacturers shifted towards smaller turbocharged engines, direct fuel injection, hybrid systems, and sophisticated engine management. Modern V8s often produce equal or greater horsepower while using less fuel and emitting far fewer pollutants. A 2023 Corvette Z06 produces 670 horsepower from a 5.5-liter flat-plane crank V8 that meets all emission standards, achieves respectable fuel economy, and delivers world-class performance. Technically superior in every measurable way. Technically, they're better. Emotionally, that's still debated every weekend at car shows across America. Today, the Chevrolet ZZ572 remains one of the most respected crate engines ever offered by a major manufacturer. It represents the final expression of the traditional American big block philosophy. Massive displacement, massive torque, minimal compromise. Used engines and complete crate motors still command premium prices on the collector market. Enthusiasts search classified ads, online marketplaces, and estate sales hoping to find one. Clean examples with proper documentation sell quickly, and its California story continues to spark debate. Some enthusiasts argue regulations preserved cleaner air for millions of people. Los Angeles air quality has measurably improved since the 1970s. Childhood asthma rates correlate with air quality. The collective benefit of emission standards, they argue, outweighs individual desire for unrestricted engine choices. Others believe they accelerated the disappearance of engines like this from public roads. They see government overreach, loss of freedom, and the death of automotive culture. They point to minimal impact from small numbers of specialty vehicles compared to millions of daily drivers. Both sides have compelling arguments, but regardless of where you stand, one fact remains undeniable. The ZZ572 became legendary, not because it was the fastest engine Chevrolet ever built, not because it was the most advanced, but because it represented a philosophy that was already disappearing. An era when engineers solved performance problems with larger cylinders, longer strokes, stronger crankshafts, and more airflow instead of software and electric motors. That's why collectors still chase these engines today. That's why hot rodders still dream about installing one. And that's why the phrase "illegal in California" only made the legend grow larger. The forbidden fruit phenomenon amplified its mystique. What you cannot easily have becomes more desirable. The ZZ572 embodied that perfectly: legal, powerful, available, yet restricted in America's largest automotive market. In the end, the Chevrolet ZZ572 wasn't really banned because it produced too much power. It was caught in the collision between old-school muscle and modern environmental standards. 720 horsepower, 9.4 liters, one enormous carburetor, and one rulebook that changed depending on which state line you crossed. It remains a monument to an approach that prioritized raw experience over refinement, displacement over technology, and emotion over efficiency. And for thousands of enthusiasts, that's exactly what makes it unforgettable.